So how did the koala get to Australia? Well, g'day everybody. Welcome back to Creation Unfolding. Today I am again with Dr. Matt McLain from the Masters University. And today we're going to be looking at one of the presentations that Dr. McLain did at the International Conference on Creationism, which was actually held in Cedarville this year, just in July. And so today we're going to be looking at something called biogeography. So Matt, I guess, first of all, just help us explain what is biogeography.
Yeah. So you just one of those, like, you gotta, they always talk about knowing what the prefixes mean in words and everything. They like doing that in science, like doing it in scripture too, right? Like, so you got geography, you know what that is, right? So you talk about continents and countries and all those kinds of things, right? And bio, meaning life, think about biology, right? So you're just saying life across the world, right? So basically, it's the science of, where do we see different animals and plants around the world and how did they get there, right? So why don't we have armadillos in Europe? Or why don't, how do we end up with penguins in the Galapagos Islands? Like those kinds of questions.
Okay. And why is this important for creationists? What's that got to do with us?
Sure. Yeah. Of course, all science gives glory to God, right? We're learning about his world, but biogeography is an interesting one because all creationists, in a certain sense, all Christians should be interested in this topic because we believe there was a global flood, right?
Right.
So God created a world, filled it with creatures, right? We read that in Genesis 1 and 2. And a global flood happened, right? Genesis 6 through 9. You have the destruction of that world and the recolonization of it.
Mm-hmm.
So what that means is the land animals we have today had to spread out from the Ark to colonize the earth we have today.
Right.
And so we would expect that we should see evidence of how they did this, right? How did they get over here and why did they go this way versus that way? And actually, in that sense, we kind of line up sometimes with what secular scientists are working on, because they also believe that animals went and colonized different places, that they didn't all start in one place. And it depends on group by group how they break that apart, but there's a lot of overlap there.
Okay, cool. Well, I think you've got the presentation that you gave at ICC. So maybe you could pop that up on the screen and we could sort of have a look at some slides there.
Sure. Yeah, we can take a little look at it.
Okay. All right. So this is your presentation. So, basically straight away, we've got some things here, Noah's Arks and Viking funeral ships. So maybe you can explain what that is.
I will. I'm not going to explain right away.
Okay.
Because we talked about biogeography, but there's a few other things I want to introduce about biogeography first.
All right. Sure.
And then we also need to talk about, we talked about why this is important for creationism, but there's an extra layer here that we haven't talked about that has to do with creationism. So let me get to that in just a minute.
Sure.
But let me just, I told you guys what biogeography is. But what I didn't talk about is what are the actual mechanisms? How do you move, an armadillo from the Ark to, the Americas, for instance?
Right.
So there's two big categories we talk about. So one of them is called dispersal, right? So when we say dispersal, what we're saying is that an animal dispersed over there. So it could be that it, if you think about like a bird or a bat, it could fly over someplace, right? Fly to an island, or maybe like if it's a good swimming animal, like a snake, it could swim for a long distance. But then you think about like, okay, well, how do other animals do that, right? How do you move large mammals, for instance, across places? And so there's some different ways, and we'll talk about one of those in a minute. But first, I want to introduce you to the other mechanism, and that's called vicariance. Okay, so with vicariance, instead of the animal being transported or moving itself, with vicariance, the land is changing around the animal, right? So if you think about, for instance, like imagine a little population of chipmunks, right? One day, a flood causes a river to change its direction, right? And that river cuts through the area the chipmunks live in, and it splits the chipmunks up into two different populations that can no longer interbreed with each other because there's giant flowing rivers in between them, right? you could end up with two very different types of chipmunks afterwards. I mean, very different, they're distinguishable. And that's one way. The other big way we talk about is plate tectonics, right? So you could imagine, and the continents are together, animals can move all around them and everything. And as the continents split apart, they're suddenly trapped and they can no longer interbreed, and you could get speciation and things like that happening. So, when we think about animals migrating out from where the Ark would have landed, and we think about, okay, well, how did they get to places like the Americas? And I said, if you're a bird or a bat or, the snake or something, it's pretty easy to imagine. But what do you do with armadillos, for instance, which can swim, but, are they going to swim across the Atlantic Ocean? And it turns out that there's a process that is called rafting. And the idea with rafting is you can imagine that when you have like a big storm, like we just had a hurricane come through this area, which is really weird for Southern California, but that happened.
I know, right? California.
I know, yeah. And so you can get these like big, like if you have like lots of vegetation on the coast, it can get ripped off, like a big chunk of it can get ripped off and can actually float out into the ocean. And if you have any animals that are on that, it's like a little boat for them. It's a little raft, and they just get carried along and they'll get dropped off somewhere else. Right. And you might think like that sounds kind of silly, but we know that happens because there's an example of this. It was a Nature paper in the 90s where they described a hurricane that came through the Caribbean. And it took all this vegetation, and there were iguanas on it. And those iguanas got moved from one island to another one where they didn't previously live. And now those iguanas live on that island. And I think it was a distance of it. I think it was like at least 200 kilometers. So it was a big distance they got transported, So you can imagine immediately after the flood, you got tons of debris, right? Scattered all over the place that animals are going to be able to go on it and get transported. And especially if you have a lot of post-flood catastrophes and storms and things, you could see this stuff happening a lot more immediately after the flood compared to today's world where it's diminished. Yeah. So we want to know, okay, how does this happen? And there's got to be a combination of things, because if you think about where the flood ends, right, in the geologic column, which you've talked about before on your channel, right. And you actually talked about this at ICC. Although you talked about flood beginning, but other people talked about where the flood ended. Yep. Depending on where you do that, there's either still continents moving around a lot or not moving so much. Okay. And that has a play in how the animals can move from place to place, right? So in the conventional way of things, they talk about something called GABI, and that stands for the Great American Biotic Interchange. Okay, so they think this is happening during the Pliocene, and this is where North America and South America come and meet together. You get the Isthmus of Panama forming, and so animals from South America can go in North America and vice versa. They can switch places.
So we're talking right at the top of the geologic column, right?
Yeah, way near the top. So this is before the Ice Age, but very close near the top, right? So you can see a lot of animals you recognize, things like dogs and camels and stuff. But there's also some weird things like, glyptodonts down here, and I'll get my laser pointer on. You got like these big armadillo like things called glyptodonts or ground sloths. And so it turns out that when you look at the fossil record, what's been argued is that for South America, through most of the Cenozoic, you find these animals that are really unique to South America. And then all of a sudden in the Pliocene, those animals start getting into North America, and North American animals go into South America. And so that's today why they argue why, there are llamas in South America and why there's jaguars and stuff like that, as they actually moved down along the Isthmus of Panama and they now live down there. And so that would be like, for instance, armadillos. That's why we'd have them in the United States today, is for that reason. And possums, the same deal with that. And so when we talk about two continents meeting and the animals switching places, there's a term for this in biogeography. It's called a Noah's Ark, which of course is fun for us because we're creationists. We like that term, but it doesn't mean what we think it means, right? So a Noah's Ark is like a big landmass that has animals on it, and it goes somewhere and drops them off, and they can go.
So this is actually a secular term, right? This is not
a secular term,
not a creationist term.
No. Right. It was invented by McKenna in 1973, I think. And so South America, for instance, would be a Noah's Ark, right? It's detached from everything else. It's just floating along, and it connects with North America, and those animals get off and go up there is the idea.
Right.
So that's fun.
Yeah.
Yeah. But South America is not the only continent in the Cenozoic that meets another continent. There's another fun example, which is India. Okay. So when we think about North America, South America colliding in the Pliocene, but India, when we look at the geology, it looks like it crashes into Asia in the Eocene. And we want to know, okay, is something like this happening when India crashes into Asia in the Eocene? Do animals come over from India into Asia and Asia into India?
Which
Because
you
that
think
one
they
doesn't get
would,
talked about as
because
much.
you've got a lot more contact going on between India and Asia than you do even between South America.
Yeah, and it's happening much earlier too, in the Cenozoic, and so there could be different things going on there.
So what are we talking? Just again for the sake of the listeners, geologic time wise, what's kind of the we know it's lower in the a little bit lower in the geologic column. What's kind of millions of years wise? How would we explain that?
So when we talk about lower and higher in the Cenozoic and everything, so for a conventional scientist, right, the Eocene, when you're talking about India crashing to Asia, you're talking about like that like 50 million year-ish range is kind of going on there, versus the Pliocene, where in South America is colliding with North America, you're talking about a range in the single digits, probably, 7 million years to 2 million years, something like that going on. And there's some debate about the exact timing of those things, but that's kind of the range. So, a good like 45, 50 million years gap going on there between these two events. So what we wanted to do, we wanted to first of all say, okay, secular scientists have been saying there's a really good evidence for animals switching places in the Americas in the Pliocene. Do we see that? That's number one. So we're going to check that.
Right.
Number two thing we want to know about, okay, no one really talks much about the India one. Do we see that happening? Do animals go from India into Asia and Asia into India when they collide? So I want to do that. But really where we want to go with this is, what does this tell us about the flood? Because there's some interesting things going on here, and I'll show you a chart in a minute to help you see why this is the case. But we're going to use this evidence of these animals switching places and these continents and everything. We're going to use it to look at 3 different flood models that are out there, right? So we're going to talk about a no flood model. So that's the conventional model, right? They don't believe there's a global flood. That's just the secular model. The next one is what I'm calling the high flood model. And so this would be there are some creationist scientists who think that the flood ends in the geologic column very near the top, right? So what we call like the Pleistocene boundary, or the Neogene quaternary boundary, like it's right basically right before the Ice Age is the idea.
So it's basically the same place that the time when North and South America collide.
Yes, very similar time. Yep.
Okay.
And then we also have the low flood model. Okay, so this would be the flood is ending at the Cretaceous Paleogene boundary, or the boundary between the Cenozoic or Mesozoic and Cenozoic. So then your whole Cenozoic is post-flood. So like where you stop finding dinosaur fossils, that would be near the end of that boundary.
Yeah.
And so here's kind of in graphical form to help people see. Okay, so a no flood boundary, right? We've got our geologic column over here. Going up here, we've got South America here and India. So if there's no flood happening, then what you'd expect from a conventional model is that both South America and India are probably Noah's Arks, right? So you can imagine the Mesozoic is going on. You have the KPG extinction right here, which kills off dinosaurs and pterosaurs and things like that, but lots of mammals and other little creatures survive, right? And so they would probably survive. There'd be creatures that would survive in both South America and India, even though they're both islands at this point.
Right.
And then when those islands eventually collide with their respective continents, one down here low in the Cenozoic, that'd be India, and one up here high in the Cenozoic, that'd be South America. When those collide, animals that are alive in those places should switch places. That's what we'd predict.
Makes sense.
Looking at the conventional model. So in that case, we have 2 Noah's Arks, right? 2 of these ships of, continent ships that drop off animals.
Yep.
What if instead we take the high flood boundary position? So this is where the flood, almost the entire geologic column is flood, right? At least the Phanerozoic is flood.
Right.
And the very, very tippy top ice age stuff is post-flood. So your flood would end way, way up
Way up
higher,
there.
right?
Yep.
So if you do that, you would expect that so India is colliding with Asia down here, right?
Mhm.
Lower Cenozoic.
Yep.
So that's during the flood in that
Right.
model.
Yep.
South America is colliding with North America even below this boundary too, just below it. Okay. Like right about here. Okay. So that would also that'd be like tail end of the flood. Okay. So what you'd predict then is that both of these, everything on those places should be dead. I mean, there may be some fish, swimming above them, and you might have some, plants and stuff, but like the animals we're talking about, like mammals and birds and those kinds of things, those should be dead on those continents.
Right.
And so when those continents are colliding,
yeah,
all that's happening is you might be moving some dead stuff onto another continent, right? Through sedimentation or tectonics, pushing things like that. And so instead of Noah's Arks, we would call these Viking funeral ships. Okay, so think about Vikings. What they would do is they put the dead bodies in a ship and they'd send it off. And they'd often set it in fire. And that's how you bury a dead warrior. Basically, is doing that. And so these are continent ships that are bringing with them dead remains. And when they crash on another continent, some of those remains are going to get placed on the continent that they're colliding with. That's kind of the idea.
Yep.
And so we don't think that there'd be anything alive.
Now, when they collide in the Viking funeral ships model, although some of the animal remains would get transferred, I mean, how far would they get transferred across the other continent?
Probably not very far. I mean, it depends on, with the flood going on, like, could you imagine a continent slamming together and then stuff that was originally over here getting reburied over there? I mean, it's possible, right? But in general, you're not expecting animals from India to move into Asia, right? Or animals from South America to move in North America or vice versa. Like it's going to be just, for the most part, pretty static, where they get buried. But like I said, if you do imagine a very chaotic flood after these things are colliding, you could get some stuff that was originally living over here that got moved over there. You could expect some.
But it would certainly be localized.
Yes.
Okay.
So you would expect that basically nothing is going to transfer over for the most part.
Yeah.
You might get a little bit, that goes over, but it should be pretty isolated is the point. Okay. And then what if instead we put the flood lower, right? What if we put it at the base of the Cenozoic, the KPG boundary?
Right.
Well, what's interesting is then that both of these are post-flood occurrences. Okay. So South America colliding North America is very post-flood, right? We're talking about it could be decades to centuries after the flood.
Yep.
Whereas India crashing into Asia, you're probably looking at either right at the end of the flood or within years to decades, right? So pretty short time afterward.
Yeah.
And so this presents a really interesting scenario where we might actually expect South America to be a Noah's Ark, whereas India would be a Viking funeral ship.
Right.
Okay, so India, if it's crashing into Asia at the end of the flood, everything on India is dead, right? All the tetrapods, the mammals and birds and reptiles and stuff. And so it's going to be recolonized by stuff from the Ark, right? And so when it's hitting, there might be a few animals that get over by swimming and rafting and stuff as it's making its way up there, but you wouldn't expect like unique big animals coming over from India into Asia, for instance. You'd expect it the other way. It should be a one-way street, right? Where everything's moving from Asia into India. South America, however, this is considerably, like we're talking about decades to centuries of floods. So you could have animals swim over there, animals raft over there. They could have speciated in South America. And then by the time South America meets with North America, yeah, you could have a faunal exchange happen.
Right.
And so we would expect then one Noah's Ark and one Viking funeral ship.
That would be
this is what's cool.
A good hypothesis, right?
Yeah. And so we can actually potentially use our understanding of biogeography to help us compare these models, right? And test these models and see what is the one that fits the data the best. That's kind of what we're looking at.
Yep.
So the way we did this is that we use something called the Paleobiology database. And if you've never checked that out before, it's a fun thing. You can go look at it, just Google it. And it's got, just millions and millions of data points. It's amazing. Basically, if something's been published out there about fossils found somewhere, it's probably in the paleobiology database. That's kind of how it goes.
Yeah.
And so we can download all that and create charts to help us visualize, okay, who's here, who's going when, those kinds of things. So let me skip ahead to these. Okay, so what you can see in this one, this is comparing South America and North America. Okay, so we got some bar charts here, right? So we got a dark blue color. That is fossils of animals, that are found in North America. Okay, so here we're looking at families, the taxonomic level of family. So the dog family or the cat family, things like that. Orange is ones that are only found in South America. And then light blue here are ones that are found in both.
So you notice the light
right at the top. Yep, right at the top.
Okay.
So when you look at the Oligocene, for instance, basically everything's either in South America, North America, right? There's nothing that's really shared. There might be a couple things, but there's not very much. So remember, we're saying that South America and North America colliding right about the Pliocene. Well, look what we see. Once you move into the Miocene, Pliocene, Pleistocene, we're seeing these other bars are growing in size. What are these other bars? Well, we have the one where they're present in both simultaneously. Gray means that a family was originally found in North America and has now been found in South America. So they've switched places, okay? And yellow is South America moving to North America.
Okay.
And you can see those bars get bigger as you're moving into the Pliocene, and especially in the Pleistocene and Holocene, right?
It's really interesting.
And that matches what the secular scientists have been saying, Great American Biotic Interchange. That looks like that's a real thing. There are...
What is the gray bar? What does the gray color represent?
Gray is they're moving from North America to South America.
Okay.
Yellow is they're moving from South America to North America.
So you definitely see an increase in both of those, right?
Yep. They're both changing. And you'll notice that more mammals move from North America to South America than vice versa, which is also something that's been talked about in the literature before too. So this is for genera. So we looked at the family level. What if we get more specific down to genera? And you see the exact same pattern, right? You start off with just blue and orange. And then over time, once you get in the Pliocene and then Pleistocene, Holocene, you're seeing animals switching places. These other colors start to appear, right? Now, the reason you see a lot less here is that very few genera are going to be found in both places, right? So if you think about the created kind being near the level of family, right? You could have an individual species that crosses over there and then diversifies when it gets there. And so you're not likely to find the exact same species on both sides, but it'd be in the same family is the idea. And so let me skip ahead again. What about India? Okay, so India, like we said, is colliding in the Eocene here when that's when it's hitting Asia. Okay, and we're going to do the same thing. Look at who's moving where. This is a reconstruction of what we think the continents look like at this time, right? So this would be in the Eocene, which some people would say is immediately after the flood. Some people say it's during the flood. And so India is this block right here. Asia are all these blocks up here. And India, what we're circling here is that there's actually some land that kind of appears there. It's like a land bridge, basically. As India's coming along, you can imagine like kind of like mowing along here. It's crumpling up some stuff, okay? Which eventually those kinds of things become the Himalayas and that kind of stuff. And so that stuff there, you can find fossils there today. And it's like, do you call it India? Do you call it Asia? I mean... I don't know. Okay, so we've created a third category, the in-between, right? And so when you look at the results, okay, you can see that down here, we're in the Paleocene. We're moving away through the Eocene here. So, don't worry about these names. Basically, it's the same thing. Over here is the oldest stuff. This is the most recent, or this is the lowest, and this is the highest in the column. And we see initially, everything's either just in Asia or India, right? But then, same thing, we start to see this land bridge appear with animals on it, and we start to see
what colors are...
So here, Asia is orange, India is blue.
Okay.
In both India, Asia is gray. And then our land bridge is yellow here. So gray it's present in both India and Asia, and the light blue here is the land bridge in Asia. It's in both those places.
Okay.
And so, unfortunately, we don't have as good of data. There's not as... India hasn't been as thoroughly documented as South America, but you can see that definitely we suddenly get fossils over here in India. Now, it could be, like I said, that there are those deposits there. We just haven't found good ones. But we don't start to find animals that are present in both or on the land bridge until later. Okay, and so this is by genus. What if we look at family, right, which is the one we said should be better? This is interesting. So same kind of thing. They're only in India or Asia. We find some that are present in both as we get along in the Eocene. And then suddenly this land bridge pops up and you're getting tons of fossils on it. And you're seeing animals that are unique to it. And so this is kind of what we'd expect to see. And it turns out when you look at the animals that we are finding in India, in the Cenozoic, the lowest part of the Cenozoic, before the collision, there are some like mammals and things like that in India. They're all really tiny things, or they're semi-aquatic. So when we talk about the walking whales, things like Ambulocetus and Pakicetus, these are present there. Well, yeah, because they're swimming animals. That's not shocking that they could make their way over to India before it totally collides.
Right.
And so then we actually broke it down by mammals and reptiles and birds. And turns out bird fossil record is not that shocking that it's really bad. But basically what we're seeing here is unlike the Great American Biotic Interchange, it really looks like the India-Asia exchange is one way. Animals mainly come from Asia into India. We see very little evidence of animals going the other direction. And that is what we would predict if India is a Viking funeral ship and not a Noah's Ark. And so here's some examples of animals or relatives of animals that you would find in some of the lower deposits in India, lower in the Cenozoic. It's aquatic animals, right? So like Pakicetus or Basilosaurus, or it's animals that are very good swimmers, like tapirs. And then once you get into what's called the Epresian, they were getting into the Eocene now, we start finding better fossils. And then when you get near the top of the Eocene, right, the last part of the Eocene, suddenly we start finding what we call megafauna, big mammals, right? So we start getting brontotheres, which are these guys over here. We start getting nimravids, which are big cat-like animals. We start getting our big rhino relatives and our entelodonts and things like that. And so that's what you'd expect, right? Is that those animals wouldn't be able to make that crossing at first. They're waiting for, India to get closer and closer before they can make that jump over there. And so that seems to reinforce that idea that animals are moving from Asia into India and not from India into Asia. So as we kind of wrap this up, what we see, very good evidence for a faunal interchange between North America, South America, and the Pliocene. They're going both ways. And some of them go in the Miocene a little bit earlier. They're probably island hopping. But once you get Pliocene, they're really easy to cross between the two. And that fits really well with either a no flood model, so the conventional model, or the low flood model, which would be putting it at the KPG boundary. Doesn't fit well with the high flood model.
Right.
For Asia, India, we see good evidence for moving from Asia into India, but we don't really see very good evidence of India into Asia. And so this fits very well with the low flood model, but it doesn't fit well with the high flood model or with the no flood model. So the conventional model would predict there should be stuff alive in India. And why wouldn't it be evolving in India and everything? And then when India finally crashes into Asia, they should go over into Asia. But we don't see very much of that. Very different than what we see in South America.
Right.
And so that fits with what we would predict if the flood post-flood boundary was near the KPG boundary.
Right. And I think, there's other kind of paleontological data too that supports the lower flood boundary as well, right?
Right. Yeah, absolutely.
So things like, 17 genera of kangaroos that appear in Australia, both before the high flood boundary and above the high flood boundary. And so the problem with that, of course, is that you've got 17 genera of kangaroos in the pre-flood deposits in Australia. That means that they made their way from Australia to the Ark. They got on the Ark, and then when the Ark landed, those same genera made their way back to Australia because they appeared in the post-flood deposits as well. And so there's lots of examples, I think, of that. in paleontological with creationists doing paleontological research. So yeah, so I think the paleontology really does seem to support that lower flood model.
Yeah, well, I can show you another example, right?
Yeah.
Armadillos. So you find armadillos in the Cenozoic only in South America. That's it. Until you get to that Miocene-Pliocene boundary, and suddenly you can find them in the US too, right? And um, if you want a high flood boundary, you've got to have armadillos only in those two places. They get killed by the flood, first in South America, then they get killed in North America and South America at the same time,
Right.
unexplainably, right? And then some of those must have gone on the Ark, and then the Ark landed, and then they came back to those exact two places, right?
Right.
And split up by genus. Some of them went North South America, some went North America, and then some were in both.
Yeah.
And so that's a really weird pattern if you have that happening. And I think that this is why, one of the reasons why, like you said, the low flood boundary makes more sense. And you've got a second issue going on there too that you kind of brought up with the kangaroos. It's not just families, it's genera, right? It's the genus level. So if we're right about the created kind often being near the level of family, we wouldn't expect Noah to take 17 different types of kangaroos on the Ark, right? He probably took one kind of kangaroo on the Ark. And so that doesn't make any sense with the record. In that case, we'd have to be like, okay, we've been wrong about the created kind this whole time, right? And actually the created kind might be near the genus level for everything. And that would, then we've got all kinds of other issues too. So it's not just an issue of them going back to the same place.
Getting all the animals on the Ark too.
Yep. Yeah. And you run into that as well. So yeah, if you visit the Ark encounter and Answers in Genesis, the one in Kentucky, they suggest their numbers for animals on the Ark based on the families we know of. They don't do it based on genus. Now, I think probably Noah could still fit everything if he did genus. I don't know for sure. I haven't seen the numbers on it, but certainly family makes it much more reasonable.
Yeah. Excellent. All right. Well, look, that is absolutely fascinating. So this was actually a presentation that Matt McLain did at the, as I say, the International Conference on Creationism, which we, again, just had in July. I did a presentation there I was on a flood panel talking about these flood boundaries. So I actually spent quite a bit of time doing some research, looking at the different positions, and was, really, I think, persuaded strongly for the lower flood boundary. Of course, my presentation was on something a little bit different. It was on the pre-flood flood boundary. And I am going to upload that video shortly for those of you who are watching. But look, we're going to have Dr. Matt McLain on again. We're going to look at some of these other ICC papers and presentations, because there was, I got to say, this year's ICC was fascinating. I think we had lots of really, really good creationist research there that's really worthy of getting out there and letting people see, what we looked at. So,
and Ken, I might mention that it wasn't just me presenting this one. So I had two students who did this with me. So one of them was a student here at the Masters University, and one of them was a PhD student at Loma Linda. So the student here was Ryan Frields, and the student at Loma Linda was Caleb Lepore. And they really did like a lot of the hard work and gathering the data and figuring out how to read it, how to represent it. I just an encouragement to, I know some of the people who watch your stuff on here are students, and like we need more creationist researchers for sure. And so you can get involved in projects like this. This is, we'd love to have more and more people doing these kinds of things.
Yeah. And again, a plug in for the Masters University. So if anyone's thinking of going to college, you're thinking of doing, chemistry, don't go to the Masters University, right? And do geology, do what else? What other subjects do you have there that would be of interest?
We have biology, and we have a lot of different emphases in biology. So everything from paleontology to environmental to things dealing with, pre-med kind of side of things and cellular molecular. And then also we'd have, engineering and those kinds of routes as well, computer science. And so and math, there's a lot of different ways to get involved in creation science. It's not as sad. I mean, we both want it to all be a geology, but it's not. This is a lot of fields.
I'm just kidding when I say don't do chemistry. My point is, there's a great university out there in Southern California that's teaching geology and paleontology from a creationist perspective. And there's just not a lot, right, when it comes to Christian universities doing that. So if you're interested, check it out. Check out Dr. Matt McLain. You can go to the university website, grab his email address and shoot him an email. So, well, that's it. Again, from me, Ken Colson here at Creation Unfolding. As usual, if you were in any way encouraged by the video, go ahead and like it. Hit the subscribe button. Click the bell as well. That'll give you easier access to more videos as they come available. And there's a website, creationunfolding.com. I've got more resources there. There's a book if you're interested in that as well. And look, as usual, continue, please, to pray just for a few seconds. I really would appreciate that. So thank you and goodbye.